of what the reality is going to be with storage around the country. So I was concerned that there's some way to get more Zerk 4 in there. And related to that, I know there was issues. I need to get that in front of me. There's some issues with the M5 and the Zerloy of having more problems in some areas. I think, Bob, you were part of that, where it talks about susceptibility to radiohydride precipitation was moderate for Zerloy, high for M5, low for the Zircaloy 4, and then susceptibility to radiohydride embrittlement, low for Zircaloy 4, moderate for M5, and high for Zerlo. So, so it makes it appear that maybe, doing all this with mainly M5 and Zerlo may not be the way to go to get what we need.
All of the alloys have a ductile or brittle transition temperature that shifts to a higher temperature to varying degrees. That doesn't necessarily mean that one alloy is more susceptible to having problems than another alloy. So that's still being considered.
The fact that there's so little variation in here. I'm sorry, go ahead.
The thing you have to remember is, while the current inventory of high burn-up rods, which is still fairly small, is Zerk 4, the preponderance of high burn-up fuel
mute off
is going to be Zerlo and M5.
Well, being at San Onofre, we have I guess we have Zerk 4, and we have a whole lot of it. So we have a large installed amount of that. So maybe it's different other places. So. And anyway, so it sounds like you don't think it's worth trying to get more Zerk 4 in there. Is that what I'm hearing?
We appreciate your comment, and I'm sure that it'll be taken into consideration as the demonstration project moves forward. The NRC will not be deciding what fuel will go into the demonstration project. The NRC's role is to review the license amendment request for the...
Yeah, well, I was actually directing this to the ones making the decision.
Okay, and we appreciate that, and your comment was certainly heard. Thank you.
Okay, so I know what that means. Okay, one more question, and I know I'll leave some room for somebody else here. On this monitoring for the lid, I know there initially when they talked about the demonstration project, we were going to get lid monitoring, but
we have an answer
since this
for
is
you.
only... What's that?
Just keep on from that for you. I'll take a shot at your previous question. Forgive me, I'm not the cladding expert at Effort, okay? But so I'm looking at some of my lab complaints for you. So actually, I'll reiterate what Bob was saying. As far as Zerk 4, the reason that M5 and Zerlo were out there is because we wanted to develop improved cladding to go to higher burnups. So the Zerk 4 is going to higher burnups. There's less of that material out there, and it's not as typical for your high burnup assemblies. They're normally going to have the M5 and Zerlo.
Well, I was concerned with the install base. So I guess that's where we're differing. And then that study that I guess Bob maybe says is not as significant as I thought it was. But I wanted to ask one more thing, because I don't want to take up everybody's time. But on the lid monitoring, I thought with the project that it was going to end up generating some kind of monitoring in the lid for the kinds of caps that we're using in the United States. But from what this is talking about, it looks like we're just trying to do it for the TN32. So is that the case, or there's no other project for trying to get monitoring in the lids of the welded caps? Is that, because I had thought it was part of this project, but maybe not.
Yeah, there's no other demonstration project is planned for canistered systems, no.
Okay, all right. Okay, that answers that.
Donna, this is Tom Brookmeyer from Dominion. Just to follow up on your comment regarding the zircaloy and the other cladding types, the available Zerlo assemblies and zircaloy assemblies that we've got, excuse me, zircaloy assemblies in the high burn-up range is very small. As we've reiterated here, the preponderance of fuel assemblies in the high burn-up range are M5 and Zerlo.
Okay, so it's really based on the inventory you have at Dominion.
That's correct.
Okay,
Are there
all right.
any other questions?
Any other individuals have questions?
Yes, this is Ray Lutz with Citizens Oversight. May I have the floor, please? I have a few comments to make here about this. First of all, I'm near the San Onofre nuclear power plant. My background is as an engineer. First of all, I'm a bit concerned that you're not utilizing various designs of casts and systems in your test. It would be very useful for the very many plants and ISFACs that are under construction and being visualized right now, for you guys who are undertaking this test to utilize all known designs of these casts, not just one design that you happen to have at this facility. Number two, I would like to see the design of your test. You also include the standard handling that's envisioned. And from what I see, this thermal soak period is not something I've ever seen before, and it's something that is new and possibly something that you've introduced into your test that is different from the standard handling. So what I'd like to see is you handle everything as you predict that they will be handled in practice. Put them out there and see what happens, and don't handle them in a special way to avoid certain things or to get things stabilized or something when they're not going to be doing that. The loading pattern sounds like one that you're doing that's specific to some testing that you're trying to do rather than the typical loading pattern. I know there's different loading patterns that are in place. Some of the different casts use different loading patterns. I didn't see any variation of loading pattern. You have one picture there with one loading pattern. And is that going to be the way they're all loaded exactly like that? There needs to be some more variation in the type of testing that you're doing. I'm additionally very concerned, and this goes across the board with all of this ISFAC and these dry cast systems, is that there's very little defense in depth planning at this point. You have a single layer of boundary that you're working with. There's not two layers. People that designed oil tankers learned long ago they had to have two thicknesses on their oil tankers to guard from accidents. You guys only have one layer. And then you're going to bring over this temporary building only when you're handling things because you think that there's going to be only a release then. Guess what? There may be releases at other times that you're not predicting. And so all of these things are concerns about your plans for this demonstration project where you're not thinking widely enough, you're not including enough different factors, and you're not including these various designs. And so I'm very concerned about this, basically, what do you call it? You've got blinders on, you're only looking at one little thing here, when you guys need to consider all of the industry and what they're doing and get a demonstration test started. The faster we get it started, the faster we can get some results, because we need this testing done. It's going to take a very long time to do it. And if you're only starting this one limited test, it's frankly quite ridiculous. Okay, so that's the end of my comments. Thank you.
Ray?
We appreciate your comment, Randy. So there's why there are no more designs. It's not really it's not a test of the dry cast storage system. It's a test of the fuel, and the fuel that was selected represents 4 different cladding types. So it's a wide range of cladding types. We feel, from the NRC perspective, this is representative of a broad range of cladding types that could be extended to other applications around the industry. Let's see, a thermal soak period, there's nothing special to the thermal soak. I think that's just what Dominion is calling it. It's a time frame within which the temperatures will stabilize within the dry cast storage system. There's nothing special, nothing different being done. The dry cast storage system will just sit there and radiate heat for that time period. But it's more, they use that term to describe the time frame within which the temperatures will stabilize in the dry cast storage system. The loading pattern is specific to testing. There's only one dry cast storage system that will be loaded, and it was picked to make sure that the heat load of this particular dry cast storage system is as high as possible with the available fuel of the different cladding types that are available there at North Anna. And defense in depth, the system that has the same level of defense in depth as the other TN32 dry cast storage systems at the site. We're going to take a very hard look at the containment features of the penetration through the lid and to make sure that they meet the NRC requirements going forward.
I just want to bring up one follow-up question or statement in terms of how the fuel, you're looking at testing how well this fuel deals with this type of storage. However, these different storage systems have different orientations. For example, the new home system is held horizontally, and maybe there's a concern about how this fuel will deal with horizontal placement, since in all other situations it's held vertically. Within the reactor core, it's vertically held, and within the fuel pools, it's vertically held, and then all of a sudden they put it in a horizontal orientation. There could be issues there that you're not investigating. So I still contend that you need to take the blinders off, take your mind out of this little box that you're in, and try to think of the various other designs that are around the country and how this high burn-up fuel is going to be dealt with in cask storage systems, and not just look at this one type of cask. I guess you're only loading one cask, is that right? Is that all you're doing? Is it only one cask?
One system, but we're very much aware of the difference in designs across the country and the different orientations, above ground, below ground, horizontal and vertical. And it turns out suddenly there's a very small difference in the temperatures that are seen when you compare a horizontal system to a vertical system. And so we've thought about that. I know that Dominion and the industry and DOE have thought about that. And we believe, based on what we know of this test, it will be representative of a wide range of fuel types around the country.
Well, knowing about it and thinking about it is different than an experiment. And I implore you to use experimentation and the scientific method rather than sitting in an easy chair and taking out your pencil and paper and trying to figure out what the heat's going to be. You have to use experiment. That's what science is all about. All right, thank you very much.
We understand, and we do utilize experiments quite a bit in our work going forward. Any other members of the public have comments?
David Martin, Chester, Virginia.
Sorry, can you repeat the comment?
Why is NRC even thinking about granting Dominion a license when North End is built on a fault line, a known fault line? We had an earthquake in 2011, and aftershocks, still have an earthquake aftershocks. Why is NRC even thinking about granting a license to Dominion Power?
Dominion has an active license for their specific license disposee. We've taken seismic activity into account, and we've reviewed in detail the results of the event that occurred in 2011, August of 2011, and determined that storage at that site is safe moving forward.
What risk factors are you using?
I'm sorry, can you repeat?
What risk factors are you using?
10 CFR, it's 10 Code of Federal Regulations, 10 CFR 72.
We still could have a major earthquake on that site and exceed the design limits of North Anna and cause a major problem.
And we've looked at that situation, that issue, and determined that continued storage is safe at that site.
No, you have not.
All right, we appreciate your comment. Any other members of the public have comments?
This is Dave Hoffman. I'd like to know if I heard correctly. There's only been one dry cask that's been opened and inspected up to this date, which was a low burn-up dry cask. And my question is, with these casks having to sit for 20 to 60 years, I would think that a very small difference in the internal conditions could result in a fairly large difference in the way the zirconium and everything else behaves inside the dry cask. So how sure are you the conditions are not different from one dry cask to another if you've only opened one? Thank you.
It's exposed as very rare consideration, and cladding only know what temperature they're at and what atmosphere they're in. They don't know which system they're in. And we've shown tests out in Idaho. We've had a number of casks in a variety of orientations with a variety of cover gases and a variety of impurities in that the only two things that matter are temperature and the major atmosphere. It's not the minor gases. It's the difference if you have air and you have helium. That's a major difference. It's different if you're at 400 or you're at 300, but not minor differences in temperature. So we do have a handle on these things.
Thank you.
Anybody else? All right, well,
Hello. Hello.
Go ahead.
This is Erica Gray again from Henrico. I just want to reiterate that site has multiple faults. The 2011 5.8 knocked the plants offline. It exceeded the plant's design basis. 25 of the 27 casks moved, some of them up to 4 inches. 2 years ago, Dominion improperly loaded a horizontal cask that exceeded the heat design basis of that cask. I have no confidence this is the wrong location for a test site. Thank you.
Thank you, Ms. Gray. I appreciate your comment.
All right, with that, the meeting is concluded. Just one last thing. Well, thank you very, very much for everybody participating in this meeting. The NRC also has feedback form. If you want, I can give you a copy, and those on the phone, please email us, and we can just send you a copy of the feedback form. Thank you.